right, good morning and welcome everybody. Thank you for joining us. My name is Dylan Tanzi, Executive Director of the SunSpec Alliance. We have a lot to get through on this exciting webinar covering SunSpec Modbus and both how to apply it and how to use it and get the most out of SunSpec Modbus devices and implementations. Next slide, please. All SunSpec meetings are conducted in accordance with the SunSpec antitrust policy and intellectual property provisions defined in the SunSpec member agreement. This agreement can be found at the following address. SunSpec strictly prohibits market participants and their employees who take part in these activities from using their participation as a forum for engaging in practices or communications that violate antitrust laws. Confidential or proprietary information should not be discussed in open session. Please contact SunSpec management if you have any questions. And with that, we have the leader of today's webinar, Vish Ganti, the COO, apologies, of DER Security Corp. Is going to be the leader of this work group, and this is of this webinar. Mix my words up today. Apologies. And this is where SunSpec's at its best, where we give our members the opportunity to talk to the community. So I'm excited to pass it off to Vish to take us through the rest of the material.
Thank you, Dylan, and very excited to really be talking about the open source community that we'll be building with SunSpec Alliance. Both in terms of working with SunSpec standards, but also activating the ecosystem through other open source projects as well. And we've done a lot of work. Last year at the annual meeting, if some of you have been present, I kicked off the open source program for SunSpec. And we've kind of kept up with that. And this is a mid-year kind of a check-in for us where we're going to be talking about a couple of projects that we're incubating, as well as other things that we're excited to talk about for later this fall. So the agenda for today, I'm going to talk a little bit about some of the tools that we've been working on. I'll give you, we have some exciting demos from our community members here. I'll introduce them as well. And then we actually have a sneak peek of SunSpec DevKit that is going to be launched this fall. And we'll talk a little bit about the SunSpec Alliance Tech Summit later in October. All right. So first up, I think everybody who's in the energy space and who works with DERs, I think one thing we can all agree on is today's DER landscape looks a lot like this, a bunch of different noodles and API integrations across the ecosystems. Whether you talk about virtual power plant use cases or DERs integrated to the grid, utilities, aggregators, or asset O&M use cases, all of this requires you to build a ton of API integrations. One thing when you focus too heavily on this interoperability chaos is that you keep security as an afterthought. That's not the first thing you worry about. You're just busy. You're just doing a lot of busy work building these API integrations. And in the world of larger systems such as commercial, industrial, and utility scale systems, we end up doing the same with Modbus, custom Modbus maps. So here with the open source program, our intent is to streamline this entire problem, and in such a way that you don't think about interoperability and security as two different sides of the coin. Instead, you don't make that trade-off. You build by design. You design for security from ground up, and that's where for us open source has a really key role to play, because we through SunSpec Alliance can bring trusted, tested, and lab tested secure protocol stacks. That's across SunSpec ecosystem, whether it's 2030.5 or SunSpec Modbus, but also add the dimension of security to it, which we'll cover later today, which is around the PKI and all the SunSpec related standards. Now, with respect to Modbus, the Modbus standard actually comes with TLS, so the security built in, but nobody ever uses it. It's like it's very open-ended even now. It's an open port protocol in that sense. So we want to fix that. So historically, speaking of which, So basically, we've always had Modbus in the ecosystem. It's the most common protocol, ubiquitous across industrial ecosystem. Then came SunSpec Modbus, which allowed standardization with respect to the schemas as well as the vocabulary with respect to how the systems work. What was missing in that was the idea that you could secure those ports. In the right side here, you can see an example of what this means for having Modbus TLS. It's like going from HTTP to HTTPS. We've done the same with web. We've done the same with FTP servers. We went from FTP to SFTP. And this is a common pattern across all of these things. But when it comes to industrial IoT protocols, there's a huge blind spot today in the market. And we think we can accelerate the adoption of secure by design protocol stacks here using the open source ecosystem. So the star of the show here is not me. It's actually the two guys who are going to be talking about their projects, and you get to hear from them directly. So the thing that we really want to unlock is basically enhanced grid security. All of these DERs are grid integrated. They're all IoT products at the end of the day. You have to think of them as attack surface, whether it's fleets of devices that can be compromised together, or whether it's individual asset, if it's large enough, can cause grid damaging behavior. So we've, in the last, I guess, like couple of weeks ago, SunSpec Alliance did another webinar related to security aspects. Here today, what you will learn is how you can take advantage of these. We have prototypes and demonstrations of how we've secured Modbus and the tools that you can take and use off the shelf through the open source ecosystem. All right, so with that, what we will cover is the first one, which is the Modbus schema toolkit. We'll hear from Niels. Niels is based in the Netherlands. Niels, over to you.
Hi, good morning to everybody else. At my location, it's now just past 7 in the evening. So let me share my screen. And that is this one. Yes. So I have created a presentation around the whole Modbus problem, around what is the meaning of all the data. So a little bit about me. I've been writing software for like 40 years now. I've been an architect for a couple of decades. My current job title is innovator. I have a history in large-scale systems design, a lot of streaming, a lot of big data, a lot of data science, and I'm currently primarily focusing on cybersecurity at the company I work for, which is Bol.com. In the US, completely unknown, but effectively it's similar to what Amazon does with you. I'm also quite a bit of an open source fanatic. I have contributions in loads of open source tools, and I speak quite a bit at conferences about these things, and the link you see there below redirects to a playlist of some of those talks. So this talk is primarily about what I have at home. I try to be energy efficient, and being a data guy, I really want to know what's going on. So I have quite a few energy related devices. I have 2 electricity meters. The one on the left is provided by our power company, which has a completely different thing than what we're talking about today. And I have, for the heat pump, a separate electricity meter by Estron. And I have a solar inverter with a bunch of panels. And I also have a heat pump. And based on all of that, I've created software over the last few years to get some insights in what these things are doing. So I made a dashboard on Grafana, and it looks like this. So how did I build that? Well, simply put, I have a chain where I have a device. I need to be able to connect to it and get the data. Then I need to be able to convert it into a form that I like, store it somewhere, and put some kind of dashboarding alerting tool on top of it so I can use it the way I like it. So back in 2019, we got a first device in this area, which was a solar inverter. The device speaks Modbus. Okay. Well, my desire is to get that data and then do something that I know, and it's InfluxDB and Grafana, tools I've been using for a long time. So I needed to write something that fits in between, something that speaks Modbus on the one end, InfluxDB at the other end. Both are ready to run tools, libraries are available to connect to each one. So I started digging and found out that this device actually does something called SunSpec. Okay, figured it out, downloaded all the models, tried to make it work. It works, but don't ask how. It's not pretty. It works only on my device, and only part of the models. And then I said, like, oh, but if I can do that, I want to have something similar for my Den heat pump. So I bought a power meter, and this one I selected it deliberately because it also had the capability of being able to get the data. Also does Modbus. So I created something similar. But now the specifications were in a PDF. So again, not too good code. Now looking at what I've done in this period, I learned a couple of things. Modbus is a protocol for which implementations simply exist. They're ready to run, they are fine. They are no need to build a new one on that level. However, adding meaning to the bits you get back is almost non-existent. Everybody reinvents the wheel again and again. And then the PDFs I got, the specifications I got from various systems are very confusing. Some notations dating back to the origin are off by 1, are base 10 oriented, instead of being a binary thing, which it really is. And something that I also noticed is that the Modbus devices I have are relatively slow. A single request takes a couple of 100 milliseconds, and that is normal. So one of the things I realized is that if you do a query for a single field, or you do 2 queries for 2 fields, or you combine them, that really makes a difference in how much time you have to wait. So optimizing the queries became a necessity, but also really hard, because some devices on some fields return an error because it's a not implemented feature on the machine I have. As a consequence, all of this code was really one-off, error-prone, very device-specific, and not reusable in any way. And then I ran into this example. My solar inverter has a model identifier, part of SunSpec. And it's a string, looks like this. And looking at the registers that describe this, it's fine. It's a bunch of hexadecimal values. You read them, and they represent this string. So if I actually read the exact string as dictated by SunSpec, it works. I get the right value. However, if I make a mistake in my software and I am off by 1, I get an error. If I'm off by 1 the other direction, I get nonsense data. And this is really important, that you really need the schema in order to be able to read the registers, because you will get problems if you do not align perfectly with what the device is actually providing. And then in late 2022, we replaced the heat pump, the old one we had, and we replaced it with a device by Thermia. And turns out that this machine also does Modbus. So I sent them an email, and literally the same day, I got an email back with a PDF with over 400 fields. Big thank you to Thermia for that. And it really taught me a lot. So now I had 3 devices, all 3 doing Modbus, all 3 doing it in a totally different way. But I wanted to connect to this one also. And looking at what I've done so far, I was facing the exact same thing again. And I said, no. I'm not going to do that again. I took a step back. What am I actually trying to solve? The underlying common factor here is Modbus. And Modbus is a binary data exchange protocol designed in the 70s. And just to be clear, this is at the time where the internet was about 200 machines. Yes, at home, I almost have 200 machines. Back then, that was the entire internet. DNS was not invented for another 4 years. HTTPS was not invented for another 15 years. So this is designed in a time when the world was really different. And the protocol is essentially a remote peek and poke. You can, just like we did in the old days on the Commodore 64, which is about the same era, you can get and put either single bits or 16-bit registers. And that is all you had. You had a 16-bit value. And Modbus does not tell you the meaning. It is a completely meaningless protocol in that sense. It is the manufacturer who has to explain to you what a value means. And that is what is called the Modbus mapping, translating the registers to their meaningful value. And most vendors do that in terms of a PDF. This is the PDF from my electricity meter. There they explain that a current, you have to go to a certain register, and then you have to get 2 of them and then interpret them as an IEEE floating point number. Okay. But if I then go to my thermal heat pump, there they also have things like a current and a voltage. There they say, no, it's a single 16-bit register, and you have to divide the value you get out of that by the scale they put in the PDF. So divide by 100 or divide by 10, depending on which one it is. And what I also found is that there are a lot more than just a few numbers. There are floats, integers, booleans, strings, enumerations, bit sets. There are lots and lots of variation in what devices can offer. And then the third one that I have is my SunSpec device. Now, SunSpec is in essence a generic standard for Modbus schema mapping for solar energy kind of devices. And they do that by making it a modular system. Each functionality, being a photovoltaic system, being a battery, having an IP address, things like that, all have a separate model. And then to create the actual Modbus mapping for a specific device, you ask the device, and that is also via Modbus, which models have been implemented and at what address. Then take the Modbus, then take the SunSpec specification of all these models and place them in the right spots. And from there, you generate the Modbus mapping specifically for that machine at that point in time. And I realized that if a system running SunSpec gets a software upgrade, it may change the models that are available. So you cannot cache this. It really has to be inspected at startup. And another thing is that, like in the other 2 examples, there is a current field somewhere. Well, in model 102, there is a current. And there they say it's an unsigned int16. Okay. And there is this. And that is actually a reference to a separate field in the model. And that is called a scaling factor. And it's a number between -10 and 10. And to get that value, you have to find the registers associated with the scaling factor. And then you get that number. And then the actual calculation to determine the value of the current field is by taking those registers times 10 to the power of that scaling factor. And as you can see, the same kind of field is implemented completely different in all of these systems. And I wanted to have a consistent dashboard where it just says current and it's so many amps. So after I got the heat pump, I started thinking and I started tinkering, and after about 2 years of tinkering, I open sourced my Modbus schema project. And it really started as just a hobby project, but it got a bit out of hand. The core goals I set when I started this is that I wanted to make a single system, a single piece of software that handles all the Modbus mapping problems for all my devices, including all the types, all the weird math, all the complexities, including all the SunSpec stuff, usable for the use cases I want. And those are read-only, optimized queries, because I want to have the data as frequently as possible. So less queries means less time. You can do it more frequently. And because of preference, because of the tools that I use, I built everything in Kotlin and Java. And another important thing is that although this project is really complex, I want it to be long-term simple in terms of adding a new device is easy, and adding a new integration and sending the data to something else is easy. After a lot of designing and playing around and trying things out, I came up with this overall architecture. I have a physical device and a Modbus implementation. Those are treated as a given. And around that, I created a more abstract Modbus device API. And this abstraction supports all kinds of Modbus notations that I've seen, and is really, really simplified to only things like give me those registers. Attached to that, I have what I've called a schema device. And a schema device is actually the thing that does the mapping. And it consists of blocks of fields. You can treat those as namespaces. I added those because in my Thermia heat pump, they have variations. They have grouped the fields per use case. For example, cooling and heating and pool and things like that. And in SunSpec, you have model 1, model 2, model 3. So it makes sense to have blocks of fields. And then there are fields, and each field has an expression. And the expression language, which I wrote for this purpose, these are 2 examples. You can do all kinds of math, all kinds of conversions. And what you see in the top one is an indication of, oh, if you find these bits, you must treat what you get back as an not implemented. So if these bits are returned by the physical device, the system will say, I don't have a value. And I also made sure that all of the expressions in my expression language follow all the normal mathematical rules on how to evaluate them. To connect the two, I have created a cache of the previously retrieved values. I keep them with a timestamp of when they were retrieved, and a fetching mechanism with a query optimizer that is only retrieving the data that needs to be retrieved, and also tries to minimize the number of Modbus calls to speed it all up. And then the question is, how do you create such a schema? Well, you can do some code. You can write some Kotlin code where you say, I'm creating an instance, adding a block, adding a field, and you have something that should work. Or you can put the same thing in a YAML file, which I have done for the other 2 devices that I have. And that is an open YAML format, which gives you the same functionality. And reading this into actual running code is only this line. It's really open the file, read it as text, and convert it. And that makes it really easy to create such an instance and start querying the device. Because I found that it's sometimes a bit hard, I also created a Maven plugin to convert the YAML-based code into actual program code. So the Maven plugin just creates code like this. This is actually a copy and paste of that. And the nice thing here is that it creates hard variables with the name of the field, and also hard codes the return type, whether it's a floating point number or a string or something else. I have tried to make this Maven plugin so generic that you can inject a custom template. So it should be able to generate any language somebody can create a template for. Right now, I haven't done that yet. I have created Kotlin and Java, and both of them work. And then there is the third way, and that is code generation, generating the schema device. And that is what is needed with SunSpec. So what I've created is an additional module that gets all the models from the official SunSpec repository, combines that with a generator that inspects the device, and from there generates the model at startup. There are a great many models, and I'd like to say thank you to the people from their security because they let me use their simulator, which enabled me to create a lot of tests around the 700 models because they had special things I had no test data for. And with their help, I was able to test and implement that correctly. So thank you. And then you have a schema device, a complete thing with a connection to a physical machine. And there you can then say, okay, I want the blocks and the fields based on their name. You can just look them up. Or you can say, I'm using the generated code. But this is still at a programming language level. And then I said, like, okay, but I have to try to make it easier to use because I have a couple of devices and other people who want to use this will also want something easier to use. So what I did is that I created a Docker image, which you can start up with the TCP parameters to connect to the device and the YAML file, and then you get a GraphQL interface. If there's time, I would like to demo that in a few minutes. And for SunSpec, I did the same thing. And because with SunSpec, all the schema definitions are already prepackaged, actually using this is just one command. And you only have to fill in the right parameters for your system. For InfluxDB, I have created a Kotlin script, which is essentially a script written in Kotlin, but it's easy to use on also Raspberry Pi systems, which I have. And it does essentially the same thing, but instead of providing GraphQL, it sends it to InfluxDB every second or so. And I've created something similar because then replacing InfluxDB client with an MQTT client, same thing. What I would like to do in the near future is also create one that does Kafka and clean all of this up to make it easier to use. But I haven't done that one yet. In case you're wondering why I would like to use Kafka, please have a look at this talk of mine from like 5-6 years ago on the Flink Forward conference about streaming systems, where I addressed that question. And like I said, I have created a GraphQL API. And because all of the code is generated from the source of SunSpec, you get in the schema definitions all the explanations and labels as they have been written in SunSpec. I do have to say that I have created a layer of cleanup in between because I wanted to make things more consistent and more readable. And then what you can do is make a query and even make a subscription where you can do where you then get the data every second. So where am I now? Well, I started with this. This is essentially what I still have running mostly, and I'm transitioning into this, replacing all of it with my library. To make it all a lot cleaner, a lot easier to understand, and a lot cleaner to run. I'm actually using the code-generated version because that, like I said, also because it makes it easier. And with this all in place, I only had to convert the 450 field PDF from my Thermia device into a YAML file. And from there, essentially run the same software. Now, because I'm now already at this point, replacing this with another protocol like MQTT is very simple. And that enables using something like Home Assistant, a tool that a lot of people have, a lot of home lab people have at home. And I have it currently only in an experimental setup, but what it does give me is that I am able to create a dashboard for my heat pump, where you see the inside and outside temperatures, the water temperature, the fact that it's doing cooling or heating, and also at the bottom you see the temperature of the ingoing and outgoing water flows to the heat pump, to the centralized pit that we have in the area. And similar for my SunSpec device. So that makes it all quite easy. So a high-level summary. In the end, I was able to create something that I see as an open Modbus mapping standard. It's machine readable. Any vendor who would like can create a YAML file using this for their device and publish it if they like. Or they can write some code like I did with SunSpec to generate it. I also created an open implementation using Kotlin, which makes it usable in things like Java and Scala and all the other JVM languages. I have demonstrated that it works with InfluxDB, MQTT, GraphQL, and a lot of others. And at this point in time, I see it as usable by tech-savvy home users. And I also see this as an open standard, the machine-readable format, so anybody who wants can just re-implement it in any language they see fit. And because I would like to see that, I've added an open license to it that makes it also easier for businesses to use. So those are the slides, and now I would briefly like to show the oh, where's my mouse? The GraphQL thing that I've created. Let me see if that works. Yes. So for those of you not familiar with GraphQL, what you're seeing here now is a manual interface where you can test GraphQL. What you see here is that I can do a query. I can give a parameter to the query saying I'm okay with the data being 5 seconds old. And I can request some things. Now, what you see here is that it says, oh, I have model 1. And that is because when I started this, when I started this, when I started this software, it read from my device that it supports model 1 and model 101. So when I now fire this query, this is live data. You see that the power coming out of my solar panels is only 130 watts. It's evening. It's getting kind of dark right now. But this is live data from my solar inverter. And what you see, and I did that for the demo, is that you can see the Modbus queries it actually did. Here you see that it included a whole query, which I call that, to reduce the number of calls. And in the second half, the model 101, it read all the fields I asked for and also the scaling factors. Now, if I run the same query again, you will see that it has queried less data. And that is because manufacturer model and such have been classified static, which means they don't change. And if they don't change and you query them, there's no need to query them from the Modbus device anymore. So you get the cached value because it's immutable. And same with all the scaling factors. It probably queried some anyway because they're in between, but the ones at the end were not queried anymore because it was not needed. And if I do the same queries in quick succession, because I've said, oh, 5 second old data is fine, it doesn't do any queries at all. And if I then replace query with subscription, and I say, may I do an interval of 1 second, I can just start it, and I get a value every second. And this makes it very easy to use. If you want to create I've experimented with Flutter, I can make a very simple app that reads the data from the device and shows it immediately. No caching, no servers, only this small layer. The nice thing about GraphQL is it runs essentially over normal HTTP. So if you want to secure this, you can put something like this close to the machine itself, and from there use normal HTTP, HTTPS, and the standard encryption systems that go there. So thank you. This was my part of the presentation, and I think Peter is next.
Yeah. I will. Before I introduce, I just wanted to make a couple of remarks. But thank you so much, Niels. This is awesome. Obviously, what this allows folks to do is to simplify the binary hell that comes from just playing with these Modbus. So, one question for you: if I'm somebody in the audience and I have PDFs of Modbus maps, and I have to take your project and use it so that I can simply convert them into SunSpec standards or other things, is it easy to do it, or how would you characterize that experience?
What I have done, for example, for both the Eastron and the Thermia, is that I essentially copied and pasted the entire text from the PDF into a text file and started editing from there. It's a tedious job, but it's a one-off because I'm converting a human-readable PDF into a machine-readable YAML file. That's a one-off task.
Yeah.
And from there, the software simply reads it.
Okay,
and
but I mean, I guess you can do that with LLMs now.
Nobody would have to do it again. Sorry,
Have
Chris.
you tried with LLMs? Like maybe LLMs can do a better job of just throwing the raw PDF and have it write JSON or YAML files.
I haven't tried it, but maybe that will help. Yeah.
I'll give that a try. But on that note, I just want to keep moving in the interest of time. We have got one more exciting demo, obviously. But so when we think about this journey of somebody who's here playing with raw custom Modbus maps, and they need to get to the other end, we spoke about the schema mapping work. What we're going to see next is how you can leverage open source libraries around the protocol stacks, as well as bridge to MQTT. So with that, I want to turn over to Peter.
Thank you very much, Vish. Let me see if I can share my screen here. One second while I find the monitor. Okay, first off, I want to take a brief moment and go off of my slides for a second, because when Niels and I were talking about what we were going to present, he had jokingly said that at 7 p.m. his time, he wouldn't have any solar generation to show in his demos. And I said, well, that's fine, because it's 1:30 in the afternoon my time. I'm going to be at peak solar right now. That wasn't accounting for the fact that I was in the middle of a large thunderstorm. So at the moment, I'm only making about 30 watts per string panel here. Hi to everyone. My name's Peter Grace. I am a DevOps engineer by day, open source enthusiast, programmer, technician extraordinaire, I guess. What we're seeing in this is the goal that I had set out when I started writing my two pieces of software, which are SunSpec RS and SunSpec Gateway. I'm a consumer. I have solar on my home, and I wanted information. I wanted data. I'm a DevOps engineer by day, and I love information. I love observability. And when you're that kind of person, you also seek out this information in your hobbies as well. And so my hobby is getting information from things around my home and getting them into Home Assistant. So as you can see here, this is a screenshot of my current Home Assistant dashboard for solar production at my house. It's extremely information dense because I'm the kind of person that likes really information dense stuff. But if you're familiar with Home Assistant, you know that it's infinitely configurable, that you can massage that data in all the ways that you might need to do so. So let me go ahead and turn on presentation mode and then go through these actual slides. Theoretically, when I hit present, it will actually present. You can do it. Try again. There we go. Okay. Of course, it didn't go to my right. The page I was on present from here. 1 second. Sorry. Pay no attention to the man behind the curtain. Present from here.
I think that should working. Oh God.
Yeah, it's just being rude here. Anyway, so the the core situation that I was in when I started writing my software is that I had this solar install that was made of tons of panels, inverters, all of those things, but I didn't have any way to get that information out. And what I did have was a mobile app, which every device manufacturer makes, and it was not giving me the information that I was looking for. I wanted more data. I wanted more information. I wanted to be able to make dashboards and show that data in my format, and not necessarily in necessarily do this in a I wanted the data available at my terms and not necessarily in the application's terms. So like I said, I'm a DevOps engineer by day. I do observability. I love metrics. I use Home Assistant for everything. Here's photos of my solar install. So you can get an idea of what kind of solar I actually have. 60 panels, 3 inverters, 3 battery cabinets. Specs are cool, but where's the data? This is my moment to say, gosh, if your organization makes solar equipment for a consumer, please spend more time on making valuable and useful apps for the end user, because even though you may think that your inverter is the piece of equipment that the user is interacting with, they're not. They're interacting with this mobile app, because they're not going downstairs to their inverter box to fiddle with the controls. They want to know what information's coming from the device. So please put some effort into that. But that's my screed there. What I had found out is that my equipment was SunSpec certified, and at that time I had no idea what that meant. So I did some research and found that there's actually this whole protocol specification that I could use. That's pretty awesome. So I interacted with my equipment, and I got access to this Modbus TCP stream. And like Niels covered in quite big detail earlier, that's a very binary hell protocol to keep running the same phrase. It is binary hell for sure. I had found the PySunspec 2 library that was available, but it didn't really fit the needs of what I was looking for when I was writing my software. And I, at the time, was really interested in getting better at writing Rust code. So I opted to write a library to interact with SunSpec. So SunSpec RS is a library that is available on GitHub under my organization, Peter Grace. It is MIT licensed. I know a lot of people are very concerned in the industry about the license for open source. Both of my projects are MIT permissive licensed. So if you want to use them for a commercial venture, I'm not going to stop you. So SunSpec RS utilizes the Tokyo Modbus library, which is a standard library in the Rust ecosystem for discussing utilizing the Modbus protocol. What I do is that I add in the logic that's required for parsing the Modbus model files, or the SunSpec model files, so that we can make those Modbus calls and get data back. There's a lot of, as Niels covered in detail, there's a lot of bit math and like weird conversions between, base 10 and binary and things of that nature. You don't have to worry about that in my library. You just tell the library, hey, get me the information at this point, and it comes back and gives you that value, whether it be string or integer or float. Using Rust's expressive type system, it gives you the right information in the right format, ready for you to use in your tools. So now that I had the library, what was I going to do with the data? In comes my second project, which is SunSpec Gateway, which is simply an app that utilizes SunSpec RS to do the SunSpec Modbus communication, and then adds the business logic required to allow Home Assistant to read that information from MQTT. So when you utilize Home Assistant, one of the easiest ways to get data into Home Assistant is to get that data into an MQTT server. So what SunSpec Gateway does is it posts the information into MQTT, but it also posts the Home Assistant discovery packets into the MQTT topics stream as well, so that if a Home Assistant server is watching that MQTT server, it can immediately know, oh, that data point is available here. I'll go ahead and render it in SunSpec. So once the app is running, magically you have data in Home Assistant. So I will show some data here. Hopefully when I hit show presentation again, I don't have to go back to page 61. But that's beside the point. So SunSpec Gateway, when it's running, so this is a instance, a separate Home Assistant instance that is running in a test environment on my machine. It's what I use to test SunSpec Gateway. And like Niels, I've had access to DIR Security's DIR Simulator, which has been enormously helpful, absolutely helpful in us being able to troubleshoot, debug our software, etc. I solved like 3 bugs in SunSpec Gateway within like an hour of getting access to DIRSim, because I finally had verifiable information that I knew for a fact was what it was supposed to be, and was able to fix some of those weird squirrely bit math problems that are hard to debug if you don't know what the source data is. But here we see what Home Assistant is rendering about their DIR simulator right now. And I have pre-configured in SunSpec Gateway some of the points that you might be looking for in an install. For instance, we're showing DC power from, I think this is model 714. But you can get this information and tweak it around as you want in Home Assistant. But I think to drive Vish's point home more deeply, this is not, my tool does not require Home Assistant. It is an MQTT sender first, and then Home Assistant gets that data. So here's a live screen of MQTT Explorer, which is just showing the MQTT server I'm connected to. And as SunSpec Gateway is running on its schedule, each point can be configured with an interval timer to let you know, or to choose how often you update a point. So you can see this flash as those data points get updated in MQTT. So the win for people who may want to be using this app for something other than Home Assistant is that the data is all there in MQTT. You could write the code that you needed to pull that data out and use it for whichever tooling you wanted to use with it. But the interesting points with this tooling is that you can choose what it is you want to publish into MQTT. So the SunSpec Gateway currently uses a configuration file that is YAML, where you can specify things like individual points that you want to have monitored, and also configure the Modbus communication. Once you have SunSpec Gateway talking to a particular unit, you can then use its inbuilt web page that shows you all of the points that it knows it can read from the device. So like, for instance, when SunSpec Gateway connects to the DIR simulator, as an example, it knows that there are 15 separate SunSpec models that are being advertised by the DIR simulator, with a total of 423 data points. And down here, we can see all of the individual models that it offers points for it. So like if we go to DIR control AC, we can see the description of the point and what that point is called. And we can even click configure, and it will tell you what you need to put in the config file for SunSpec Gateway to get that data into your MQTT server. So let me go back to this, and hopefully, you're killing me here. So I will go with the don't do that with me. Oh, I can't roll backwards. Anyway, let me go back to the screen here and just talk from what I remember. The key things that I want to drive home with SunSpec Gateway is that it's meant for consumers, but it doesn't have to be for consumers. The because it's meant for consumers, I am intending to make the software easier to configure for end users by allowing them to configure it in the web app as opposed to having to configure a YAML file. But I'm a DevOps guy, so like YAML files are my bread and butter normally. So like that's why I wrote it to use a config file first. But I understand that like having to click through and then write a text editor to like add things is kind of burdensome. And also, for those who may be curious, SunSpec Gateway does support Modbus TLS, like their security has been discussing. I had that added in, I think 2 months ago now, at their request, and it works just fine. In fact, DERSIM and SunSpec Gateway are talking TLS right now in my test environment. So that is pretty much everything I was intending to discuss with this.
Awesome. Thank you so much, Peter. And actually, it's pretty exciting to showcase in real world that you could use SunSpec Modbus with TLS. SunSpec aims to have a PKI and, down the road for this, have mutual TLS and other things. But this is exciting. So I want to take it home with a few key points and announcements. So what you heard today are the 2 projects that kind of address this part of the problem statement, and including to this point. But we don't want to stop here. These were only starting points. We want to engage the community and find really noteworthy projects. There's one more project which allows you to use SunSpec Modbus on RS-485 and on ESP32 kind of microcontrollers and processors. But we don't have time for that project coverage today. I do want to make a quick announcement that SunSpec Alliance is also trying to compile a bunch of these projects and put what's called a SunSpec DevKit. We want to announce this at the Tech Summit that's due in October. But I have a quick preview of this. I want to take a couple of minutes and show you what the SunSpec DevKit effectively is going to do. So it leverages a lot of the open source projects that we have, and it's intended to have easy ability to query schemas, look at different grid codes, and adjust the parameters, export models in JSON, so you can take it and use within your own products. Also have pre-built SDKs and libraries for SunSpec Modbus and IEEE 23.5 in exportable in various languages. So, we will slowly release these things feature by feature. I think we're talking about, how to time it. It's also going to feature a single DERSIM. So in the open source world, you could actually just launch a DER security simulator, run it, and start producing the telemetry. And if you actually, are a SunSpec Alliance member, you get 3 simulators as opposed to a single simulator. And if you subscribe to the Pro version, you get access to about 10 simulators, so you can start doing more scale testing, etc. It also will be directly natively integrated with the SunSpec product registry, so we can pull in device models, etc., that we post on SunSpec product registry with the PIC certificates. So you can pull those into this DERSIM and allow you to effectively instantiate a device that you've already certified, and you just want to emulate a digital twin version of that certified product. So we are opening for now. We have an interest form, so please scan this and express your interest if you want to be an early adopter or a developer. Beta test it with us as we roll out these features and compile these projects. So we're very excited. Please, you can access this form. I'll also paste a link in the chat if anybody wants to just take the fill this out. Besides that, I want to turn it over to the SunSpec team so that they can take it home with the SunSpec Tech Summit announcement.
Awesome. Thanks, Vish. And actually, with the time available here at the end, we actually have one additional guest speaker. I want to invite Arilla Barnes to give us a couple words on EIoT before we wrap up. If we do, just a quick announcement, if we do go over time and you need to drop off, this webinar is being recorded and we will email out both the deck and the recording. So if you're able to stick, if we go over and you're able to stick around, please do, but we'll distribute everything afterward.
Hello, everybody. I'm Arilla Barnes with Energy IoT Open Source, and SunSpec was one of our sponsors for the first ever energy hackathon during San Francisco Climate Week. We have an exciting announcement. Now we have, thanks to a grant from Astera Institute, the first ever open source lab hosted at Port Lab, where you can experience firsthand a solar inverter, a discovery battery, a mega gizmo power, mega carport, EV charging, etc., and collaborate with us on open source projects like the ones showcased by Neil and Peter, and other that intersect the microgrid space, the open source, and community. And what this lab enables us to do is showcase a tour. Our first tour is August 27th. Luma tickets are available to have a two-hour tour and intro to microgrids and safety around this equipment, and learn more about other programs we plan. What we would like to do is also SunSpec focused mentorship that can link what the Modbus space is doing with other energy projects, like, for example, microgrids, HIFE, and the LF Energy, and beyond. Beth Bohofer is our CEO, and she is available locally at Port Lab 2 hours a day. Reach out to us for sponsorship, for volunteering, for mentors. We are here to get the knowledge and the expertise from people like Peter and Neil and multiply it 100 times through LFX mentorships across the globe, and partner with organizations like IEEE Smart Village to deploy and field test those learnings. We're currently incubating an open AMI solution with IEEE Smart Village, Array Cameroon, and N-Access. So thank you, and I'll give it back to Sam.
Excellent. Thanks so much, Arilla. And thanks so much to all of our speakers and presenters today. Really good in-depth webinar and content, learning all about how to get the most out of Modbus and SunSpec Modbus and the entire energy system. So thank you, everybody, for your attention. Please do reach out to SunSpec to learn more and to get involved. There's a lot of important activities going on, including the development of the SunSpec Modbus Workgroup, where we are finalizing the Modbus TLS security compliance and testing criteria. It's an important new next evolution for securing the Modbus network. Vish alluded to at the beginning of the webinar.
Awesome. Thank you, Dylan. And please reach out to me. I just left my email as well if you want to talk about how to engage with this open source community. We need more contributions from companies, adopters who are building these things. And in an ecosystem which is very, especially right now, given the political situation, I think I personally believe that open source is an insurance, if not anything, against any perturbations in the market. And united and collectively, I think we can accomplish a lot more than individually trying to reinvent the wheel and spend millions of dollars trying to write this glue code and integration code. So our aim is to simplify adoption and have people think about security and interoperability on the same side of the equation. With that, thank you so much. Appreciate all the effort from our open source members.
Absolutely. Thanks, everybody.
Thank you, Vish. Thanks.
Thank you.